Dear friends, today I have a very interesting question from a chemistry teacher, Ramu Sutradhar from Agartala, Tripura, and he writes that the orbital angular momentum in s orbital of an electron, of course, is zero. That means m into v into r is equal to 0. What does that mean? M is equal to 0. The electron doesn't have any mass in s orbital, or v is equal to 0, it doesn't move, it is static in s orbital, or r is equal to 0 means the electron is inside the nucleus. So how come the orbital angular momentum in s orbital is 0? That is the question from Mr. Ramu Sutradhar. Okay, so it's very interesting, and I use this to tell that our world is a quantum world. It's not a classical world. When we say angular momentum is equal to m into v into r, the picture we have is that there is an origin, particle has a certain velocity, and then you calculate that m into v into r and so on. For circulating particle, that is the picture we have in mind. Niels Bohr, thanks to Niels Bohr, who gave us this picture that you have a nucleus here and the electrons are going in different kinds of paths of some specific radii. And for the first one, which we call s orbital, the electron goes in a circle of a path something like 0.053 angstrom or so, hydrogen atom. But if it is a bigger multi-electron system, this will be different. But it goes in a circular path. Now, this was the beginning of quantum mechanics. And that Niels Bohr was designing something which could explain the discrete hydrogen spectral lines, wavelengths. And then he came out with this idea, which worked very nicely. And it is so simple idea that electron goes in different specific circles, and those circles, which circles, is decided by that this m into v into r is an integral multiple of Planck's constant h divided by 2 pi. So that is how that MVR comes into picture, circles come into picture, and so on. But then this model of electron going in circles of specific radii did not work for anything other than hydrogen, right? Hydrogen atom. So it was a long journey, some 10 years of intense work by all the big scientists, and then we came to the quantum mechanical picture, in which we always talk in terms of wave functions. No position of the particle, no velocity of the particle, do not have these kind of discrete circles or orbits and so on. So there the angular momentum is also of two types. One is called orbital and one is called spin. Once again, the words can confuse, because when we say orbital, somehow I have in mind an orbit. That's okay. Orbit is okay, orbital is okay, but not as a circle. That's the important part of the quantum mechanics. Similarly, the spin. The spin is not that electron is spinning about its own axis. No, absolutely no. Any kind of motion in a space is covered by orbital angular momentum, and this is an extra, this is intrinsic, this is built in, it doesn't correspond to any kind of motion. So all those things came into picture, that wave function is now the god. Okay, so the atom is, or the electron in atom is described by a wave function. A function which is a function of, let's say, x, y, z, or position. And that wave function is a continuous quantity. At every x, every r, every point, it will have some value. And for s orbital, that we say that it is spherically symmetric. This function is spherically symmetric. That means this side, this side, this side, this side, this side, that side. The wave function does not depend on angles, does not depend on directions. It only depends on the distance. But you have a wave function here, you have a 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 function here. Right? But most of it is confined in a spherical volume. So now your S electron is not going in a circle, it is confined in a spherical volume, a cloud, a spherical cloud. Similarly, your P and D and 2S and 3S. So everything has a different description, but it's all continuous spread. It's all continuous spread. So you do not have NR, you do not have V, and of course mass is there. So this description is a classical picture. Many times classical pictures are very good even for quantum phenomena, but many times they are not. And here they are not. So, and this is your quantum picture, that when you do all that quantum mechanics, then you find that in the lowest energy, whatever is that orbital angular momentum, not this m into v into r, whatever is that orbital angular momentum is zero. For lowest energy, that is zero. So that is our 1s orbital. Similarly for 2s, 3s, etc. This orbital angular momentum in quantum mechanics will be zero, not m into v into r.